Very similar to a grade 11 question, but this time they give us a domain, and the domain is a little bit different than what we're used to. It goes from negative pi over 2 to 3 pi over 2. They also want us to write a general solution. So as far as solving it, one of the things you're going to find yourself doing over and over again, which is a good strategy, is just solving like normal between 0 to 2 pi or 0 to 360 degrees. And then worry about general solution and domain and other things after that. So for this question, I'm like, oh, I have some like terms. Probably what I would do is I would subtract cos x on both sides. And I would add 4 to both sides. Can you see then you would get a negative 2 on the left-hand side and 3 cos x on the right-hand side. If I wanted to get the cos x by itself, I would have to divide both sides by 3. Is 2/3 on your unit circle pie plate? No. So what we need to do is we need to take out our calculator. Since the question's in radians, we want to make sure that our calculator is in radians. So I hit my mode button, make sure that I'm in radians, and I am. And when we're finding our reference angle, it's very important that we always do the inverse of the positive value, 0.841. I'm going to write that down. First, I'm going to write here, I'm going to show my work so that you have it in your notes. When finding any reference angle, that always has to be positive. So we figured it out to be 0.841. I sometimes put 3 dots there to say I didn't round early. I'm keeping all of my decimal places. And then, according to my CAST rule, if cos is negative, I would be looking in quadrants 2 and quadrants 3. So in quadrant 2, I would take my reference angle and have to go pi minus my reference angle. So what I'm going to do right now is I'm going to hit my store button and store my reference angle as x so I can use it more than once. And I want to do pi minus my reference angle for quadrant 2, and then pi plus my reference angle for quadrant 3. Rounded to 3 decimal places, 2.301. Does this tell us the nearest hundredth, so we don't have to go to 3 decimal places? On the exam, they won't tell you, and they'll ask you to go to 3 decimal places. In a question, if it tells you, you have to read carefully, 3.9. So we get our 2 answers. And the answers we found, making a little note here, I just solved, I thought of my unit circle, I thought about going once around in the positive direction, solve between 0 and 2 pi. Now, in the blue box though, the question is not looking between 0 and 2 pi. It has negative pi over 2 to 3 pi over 2. Right? And when they have the negative values, when you're thinking on your unit circle, you're always starting at 0. So when I have negative values and positive values, well, it's going to have 0 to 3 pi over 2 in this direction, and 0 to negative pi over 2 in this direction. So I would look at this as far as my thinking would go, my domain on this question, when it's written like this, did it have the equal sign with each one? No. really particular. This one didn't have an equal sign. It's not going to affect our answer, but I want to be paying attention. Okay? This means I'm going to go from 0 to 3 pi over 2, that's in the positive direction. And I'm going to go from 0 to negative pi over 2 in the negative direction. Can you see that 0 is in between here, in my domain? But when we think about our pi plate, we always start at 0. So it's kind of hard to think starting at negative pi over 2 and going to 3 pi over 2. But what this means is we are looking for, if I show this on my unit circle, I'm looking for answers in the positive direction here, and I'm looking for answers in the negative direction there. And the answers we found was a quadrant 2 answer and a quadrant 3 answer. So we had some answer here and some answer here. Can you see those green lines are only affected by the blue part? Which we solved between 0 and 2 pi. This answer is also between 0 and 3 pi over 2. This answer wouldn't change. The one in quadrant 3 is also between 0 and 3 pi over 2. It wouldn't change. So sometimes you're going to have to change answers if they're not in the domain. But in this case, they happen to both be the same. Then the general solution, because the question also asked us to find the general solution. X would equal, and we just take the answers we found between 0 and 2 pi, which are these two, add 2k pi to each of them, and define k to be an integer. And that writes all the coterminal angles with the ones that we found. So to recap, what did we do? We solved like normal. So first of all, I had to get cos by itself. Combine my like terms to get cos by itself. Then we find our reference angle. Important to remember that when finding a reference angle, you're always doing cos inverse of the positive value. If I would do cos inverse of the negative value, it gives me a different number, and it would probably give me 2.30, but I wouldn't be able to find the 3.98. So we need the reference angle to find both answers. And then once you have your reference angle, depending on which quadrant it's in, we had quadrant 2. So this answer here was pi minus our reference angle, and this answer in quadrant 3 was pi plus our reference angle.
So if it wasn't in the domain, for example, say the domain was a little bit smaller and the quadrant 3 answer, would you get rid of it?
So what you would do, so let's say in this example, cos happened to be positive.
Yeah.
You found your answer of 0.841 in quadrant 1. That answer would be fine, but you would also had an answer in quadrant 4. And that quadrant 4 answer wouldn't fit in the blue. So you'd have to X it out and replace it with what's coterminal as a negative answer. So if my reference angle is 0.841, in quadrant 4 as a negative answer, that would be negative 0.841. And I replace that with, we'll get some that we have to do that. Just so happened they kind of made a bad one as the first example where you didn't have to change it. So you found your answers between 0 and 2 pi. We checked them with our new domain, and they happened to be actually still in the domain, so we didn't have to change them. Sometimes we're going to have to change them. And then our general solution steps from the other day, the general solution was solve between 0 and 2 pi, normally, which we already did. Then take all of your answers from 0 to 2 pi and just add 2k pi to them. That's general solution is just that one new step to add the 2k pi to your answers. Okay, let's look at part B. It involves cosecant x And then the domain that they give us is negative 100 degrees less than or equal to x, less than or equal to 180 degrees. And then also write the general solution. So our trig function this time is cosecant. Doesn't matter which trig function you have, you would like to get that by itself. So I can get that by itself by dividing both sides by the square root of 2. Unfortunately, there's no cosecant button on your calculator. So we have a problem right now that we are stuck if we stay in cosecant. But cosecant is related to sine. They're reciprocals of each other. So either you could change the cosecant to 1 over sine and then get sine by itself. Okay? So this is option 1 is not, like, I'll show you the shortcut and I'll show you why it works. So this is the definition of cosecant. So because they're reciprocals, the shortcut says you can write sine x and just take the answer that you had and flip it. So I had negative 5 over root 2. I can just flip it as root 2 over negative 5. Why am I allowed to do that? Well, if I actually used the definition and changed cosecant to 1 over sine x, this is what I would get, right? Now I want to get sine x by itself, but it's on the bottom in my denominator. What would I have to do? I'd have to multiply both sides by sine. If I did that, and I multiplied both sides by sine, well, then I would get the sine x up over here, right? If I multiply both sides by sine. But I still want to get the sine by itself. So do you see you're going to have to multiply by the root 2 and divide by the negative. So it's much quicker just to take, in the end, the fraction's just going to flip. Yes.
And that works for everything.
And that works for secant, cosecant, and cotangent. Okay? The number one thing to realize, though, and I saw it on some of you did this on the take-home quiz, the angle doesn't change. Think it was on the take-home quiz you had cosecant of pi over 3, and people tried to do sine of 3 over pi. This is the angle. This is bad. The angle never switches. But you could figure out instead, if you figured out that sine of pi over 3 was root 3 over 2, this is what would flip. The answer is what flipped, not the angle. But you're going to get tempted to sometimes flip the angle instead. I'll specifically try to give you questions where you're tempted to do that. See if you can restrain from the temptation. So we never change an angle. We do change the ratio or the fraction that it's equal to. Okay. I'm going to erase this little bit. Come back to our question. I'm going to and say, so we got cosecant x by itself, and then we can change the sine x just by flipping the answer. The angle stayed the same. Is root 2 over 5 on our pi plate? No. So we need to find a reference angle by doing sine inverse of the positive value. This question is in degrees. So now I go to my calculator, and you're going to have to switch back between radians and degrees quite often. So now I switch to degrees, and I go sine inverse of the square root of 2 over 5. Again, it's the positive value that I'm plugging in. It tells me a reference angle of 6.43 degrees, 6.4299. again, I keep a bunch of decimal places for now, according to my cast rule. Sine was negative, so we would be looking in quadrants 3 and 4. So I would then write x equals, in quadrant 3, it'd be 180 plus 16, and it says to the nearest degree, so I can now round that just to 196 degrees. And 360 minus 16 degrees, rounded to the nearest degree, 344. Again, I'm going to make a little note. Very typical to always start by saying your answers in the first time around the circle. So 0 to 360, I found my two answers. But now we're going to run into a problem. Because what is the domain in this question? The domain was negative 180 degrees. Oh, I have to check. Did they have equal signs under both of them?
No, that's correct.
This is, they had okay. So that is the way they wrote it. So what does this mean in positives? This is 0 to 180 degrees in the positive direction, and 0 to negative 180 degrees in the negative direction. See how I use the 0 to break it up? Question? Yeah. So if I look at what this means, I have in the positive direction these answers, in the negative direction these answers. Where were our answers? We had an answer in quadrant 3 and an answer in quadrant 4. So we had an answer here and here. And we wrote them as positive. So we have to go back. I'm just going to lightly put an X through this one and an X through this one. Because my actual answers will be X equals in the negative direction. I like to think if this is 180 degrees halfway around, does it make sense that this one here would be 180 minus my reference angle? 180 minus 16 is 164 degrees, but now it's negative. And this one, the reference angle is 16 degrees, that'll be minus 16 degrees. So this is an example where we had to switch our answers based on the domain. Because our answers were in the red part, and we had to write them as negative answers. Where initially, we had written them, like, we had written this answer as a positive one, and we had written this answer as a positive one initially. So we had to change them and to the negative answers. Then the general solution. General solution says solve between 0 and 2 pi. That's why I kind of like our answers to begin with. Because we did this already. We had 196 and we had 344 degrees. And since it's in degrees instead of 2k pi, we have to do plus 360 degrees k. Still define k to be part of our integers. If you flip to the back of the book, or not the back of the book, because the answers are for this, if we look, the answers to this question are on page 600. You'll notice that they actually used the negative 164 instead of the 196, and they used the negative 16 instead of the 360. That's also right, because they're coterminal. You can use any coterminal one as your starting point. Because when you add 360k, you hit them all, no matter which one you start with. Personally, I like starting with the ones between 0 and 2 pi or 0 and 360 degrees. But if you check your answer and the answer in the back of the book are a little bit different, but your answer and their answer are coterminal, then they're exactly the same. All right, questions to circle 6 and 7.